FrSky Taranis you can use for now two current sensors. 40 amps, be sharp please. Hello, be sharp. I'm too close. Yes. 40 amps and 150 amps. Both are sensor with smart port. So you connect this sensor to receiver with one actually servo wire between sensor and smart port on receiver. This will be with standard setup with new FrSky receivers XAR, X6R, etc, etc. So new receivers with smart port. You just connect connector to sensor and sorry, it's true. And second connector you connect to your receiver on smart port connector. That's all. In your Taranis you must later select values which you want now. This sensor will or can tell you current, voltage, and Taranis can count power consumption. Yes, maximum 40 amps. This is important. Second sensor is 150 amps, again with smart port, so only one wire to receiver, but with different type of connection. I will show you later. Now this 40 amps. Of course you must connect two sensor, not only receiver but battery. In my case this is some small 2 cell. Just connect battery to your sensor, and of course on other side will be probably any ESC or speed regulator, how you want. And that's all. Yes, maximum 40 amps, smart port compatibility. How you can see on, I now will disconnect it. On sensors are XT60 connectors. What is nice for you if you use XT60 connectors, but it could be a little bit problem if you not use this connector. How you can see on this sensor, you can see two these connectors. On sensor are two servo connectors or 3 pins connectors. Because one connector you will use for connect to your receiver on smart port, and on second connector you can connect next sensor with smart port compatibility. Yes, you can connect one sensor, next sensor, next sensor, next sensor. Yes, how easy it is. So now I will put this sensor in one small airplane, and I will show you how we must ask Taranis for values from this sensor: current, voltage, and power consumption. 150 amps current sensor is a little bit different from 40 amps. 40 amps sensor is connected to battery and to ESC or speed regulator. But 150 amps current sensor is connected to speed regulator. Actually is not connected to speed regulator. You just put inside this hole plus wire from battery in direction with this arrow. So battery or energy is coming from my battery here, you can see, from my battery in this direction through this sensor, and that's all. Yes, that's all. And you must only connect your sensor with smart port again to smart port on your receiver, and that's all. It's connected. Yes. Of course, it has some plus and some minus. Minus, or maybe for someone minus, is if you use battery with these connectors, it could be a little bit difficult for you use this sensor, because you must on your speed regulator you must unsolder or disconnect this plus wire, put sensor on this wire and solder it again, and of course your sensor will be for forever connected with this speed regulator, or you must unsolder this. Yes, disconnect this. Next minus or disadvantage is this sensor not measure a voltage of power battery, main battery. This 40 amps read current, voltage of battery, and Taranis will count power consumption in milliamp hours. This sensor measure only amps, and Taranis will count power consumption in milliamp hours, not voltage. This sensor not know nothing about voltage of main battery. But big advantage of this sensor, I think, is safety of usage, because this sensor is between battery and speed regulator. If you will overload this sensor, or if this sensor will have some problem and it will burn, or just it will be damaged, you cut your airplane from power and your airplane will be crashed probably. But in this case it is without any connection, only wire inside the hole, electronic is beside, without any connection to this to energy from battery to speed regulator. So I think this is more safe. Yes. So now I will connect first this 40 amps and later 150 amps to airplane, and I will show you on radio how you must set radio for read write values. So now I have inside a small airplane 40 amps current sensor connected and switch it on, and now I will show you what you must set on Taranis for write value. So press on menu and go on last screen, screen 12 from 12. Go here down and we will set on screen here, screen 1 from a few screens, telemetry screens. On telemetry screen number 1 we want value on first position, for example voltage, because 40 amps sensor can measure voltage of main battery, connected battery. So go and find value VFAS, this VFAS. Yes, this is voltage. Next, for example, current. Yes, current, here, current, and next will be consumed power consumption. This is value, this CNSP, consumed power. Yes. Now we will switch on telemetry screen, press longer page, and press page. This is our screen number 1. Voltage is 0. Why? Voltage is 0 because I have disconnected current. I have disconnected current sensor from receiver. So now I will switch on connector to smart port on receiver. My mistake. And now you can see right value. So VFAS. So voltage of battery connected to current sensor. Current in amps is now 0, and consumed power in milliamp hours 0 I will turn on motor or throttle only slightly because it's night and near me are my sleeping daughter and wife, so only small throttle. Yes. So voltage, current, so you can see 1.1 amp now, and after a few seconds we will see some consumed power. Yes. Oof. So voltage current now 0 and 1 milliamp hour consumed. So now I will show you how you can set voice messages about these values. Press exit, go on menu and go on page 11. We can set it under special functions. So special function 1, for example. So which switch, I will zoom out for look on our switches. So for example, I want set, if I will switch this switch on, I want a message about actual voltage. Yes. So it means switch SH down. Yes. And what will to do? Go on value, play value. Here, play value. And which value? How I say voltage. Remember VFAS. Voltage from this current sensor. Here we are close. Fuel, speed, distance, VFAS, yes. And play it one time. So we can try it.
7.7 volts.
Yes, again.
7.7 volts.
And now I want set. I will zoom out a little bit. Now I want set, for example, on top position of this switch actual current. Yes, on top position. So we will create new special function. So which switch? Top position on this switch, SD arrow up, again play value, we say current, actual current, this current, and again one time, or for example now not one time as in the previous case, but
0 amps,
but each 3 seconds, again and again, if is our switch on, SD on top position. So we try it.
0 amps, 0 amps, 0.1 amps, 0.1 amps, 0.1 amps, 0.1 amps, 0
So.
amps,
And now we will set on down position of this switch actual just consumed power, power consumption. So special function free, so switch SD down, again play value, and consumed power CNSP. Here CNSP one time. So top position current,
0 amps,
down position consumed power.
1 milliamp hour,
Again,
1 milliamp hour,
and on this switch we have voltage.
7.7 volts,
But we can all this set on one switch. For example, center position of this switch.
Seven point seven volts, 7.7 volts, 7.7 volts,
It means switch C center position.
7.7 volts, 0 amps, 7.7 volts, 0 amps, 1 milliamp hour.
Yes, and if we have more values on one switch, it will just read it in this order.
7.7 volts, 0 amps, 1 milliamp hour, 0 amps.
Yes. It, of course, right will be if here will be it second one time, same like on right, different values.
7.7 volts, 0 amps, 1 milliamp hour.
So, and how we can set message about any level of consumed power. For example, we have in our airplane battery 2 amp hours and with capacity 2 amp hours, real capacity, not only about number on battery, but really real capacity of our battery. Checked by charger, for example. So we have in our airplane a battery 2 amp hours, and we want message, for example, that we discharge 1.5 amp hours, so 1500 milliamp hours. So press on logical switches, and we will create logical switch which will be switched on if value A will be bigger than X. Value A is consumed power and value X is our 1500. So A is, how we say, consumed power, so CNSP. Here, CNSP, and how we say 1050 milliamp hours. Okay, so logical switch 1 will be switched on if consumed power will be bigger than 1500 milliamp hours. And on next screen we will create special function number 4, where switch will be our new logical switch L1 from previous screen. Where is it? Here, L1, yes, logical switch L1. And if switch L1 will be switched on, so 1500 milliamp hours will be discharged. So just play value like in previous cases. Play value of consumed power. Here one time. So if will be switch on logical switch L1, consumed power is bigger than 1500 milliamp hours, it will be play actual value. So it will say 1500 milliamp hours. Yes, of course you can create custom your own message. For example, hey idiot, your battery is almost empty. Copy this voice message inside the Taranis and play this value instead this actual value. And now,
Welcome to OpenTx. Switch warning.
now I have connected 150 amps sensor, current sensor in my airplane. So we can look on our screen and we can see VFAS voltage is 0 because how I say 150 amps is without a voltage measurement. Yes, so we can see only current about 0 and 0.1.2. 150 amp sensor is not so precise like 40 amps, but how I say, I think it's more safe. And of course if it is not precise about 1.1, 1.2 amps on 100, on 150 amps, it is not so important. Yes, and everything other is the same like with previous sensor.
0 volts, 0 amps, 1 milliamp hour.
Yes.
0 volts, 0.4 amps, 1 milliamp hour. 0 volts, 0.4 amps, 2 milliamp hours.
Yes, so it's the same but without voltage and with no so precise measurement like with this small sensor. But how I say again, I think 150 amps is more safe. So thanks for your watching. I hope that it could be helpful for you, and have a nice day.